Hello everybody, welcome to this Fluid Power webinar in Automation Studio. So the goal of this webinar is really to give you, in the new interface of the version 6 of Automation Studio, some best practices to make you able to design your hydraulic or pneumatic circuit. So if you just quickly explore this new interface as it was presented last webinar last week. Okay, so there is some tab here that shows some comment in the ribbons. Basically, we're going to explore most for this webinar the Home tab, where it contains all the commands you may need to start designing properly your circuit. Okay, and we're going to go through some other tabs later in the presentation. Okay, first, what I will do, I'm in front of a blank sheet of paper. To start designing, I will go into the View tab and I will activate the grid to make sure that every component will be aligned on this grid. Okay? I return in the Home tab and I open my library. You will see that there is two library types. There is the main library, and we've got also the catalog manager that will be covered a little bit later. Okay? In this library, it contains some generic components. Okay, so we use this library for design a circuit without knowing which manufacturer components you want to use in your circuit. Okay, so if we extend this, you'll see that now there is only one branch for hydraulic, and it contains also some proportional component compared to how it was in version 5.7. So the philosophy of drawing with this version 6 is still the same than what it was in version 5.7. So you just need to start putting some components on your schematic. Okay. So what we suggest is to put the component on your schematic, approximately where you want them to belong. Okay? So what I will do, I will start building a typical flow control circuit for mobile hydraulic. So what I will need, I may need some flow valve. You will see that there is some component blue with blue background with a plus sign. It means that there is some similar component if you double click onto this this blue area. To change the symbol you want to use. So I'm put these components here. Okay, I will put one like this. I will need also a shuttle valve. I will use a smaller component. I will put something like here. Okay. I will put a directional valve. You go there, simplified model for now. I insert my four-way valve here, okay? And I'll return in my flow valve, and I will insert a flow compensator, okay, a pressure compensator, sorry, to control the flow, okay? Once all your components are placed approximately where you want them to belong, okay, you will see that you can use some layout tools to properly change the layout of your component. To do this, you go in the Edit tab. So what I will do, I will flip this component to make sure I will have a meter in control circuit. So I select this component, go in position, and I will rotate it, okay, 180 degrees. And what I will do, select this component. You can copy and paste the component, okay, or you still be able to use in this version the Control key. So I hold down the Control key, and I'm able to directly duplicate this component, okay. Right here. Okay, so when I have my component inserted, I just link them directly, automatic insertion for T-connector. You can move the component back to the circuit, and you just complete easily, okay, your circuit. So I click one, it will fix one direction. Here we go. And I complete the layout of my circuit like this. Okay? Of course, here this pump may not be the one that I want in my circuit, so you still be able to use the shift key to remove components, okay, and insert an appropriate one to do what you want with your circuit. So I will search for a load sense pump here, okay, with drain, and this one that I will insert in my circuit. Okay? And like that, I will be able to go here and connect my load sense port like this. Okay? Still be able to duplicate the reservoir for drain and another one for my return line. Here we go. So once your components are drawn properly, you can frame and change a little bit the layout of the lines for your circuit. Okay, you click on the line with the grips, you change the line as needed. Okay, now that I have my circuit like this, okay, I will show you how you can still use some tools here to really frame a group of components. Let's pretend that these components is inside a manifold. Okay? And here you go. You just frame this. If you want to make the circuit a little bit more realistic, or if you want to reuse what is inside the block, I will suggest you to use what I call my manifold tool block, this break link command here. I activate it, and I'm able like that to go in the boundaries of my manifold and really start cutting or breaking these links as needed. Break link just at the boundaries of your manifold. Okay, I used to call this feature the manifold feature. Okay, so you draw your circuit, and after that you activate this command and you really break the lines, okay, at the boundaries of this CAD object. Of course, you can change the layout of this CAD object and use a line style that looks more like a manifold. Okay, you go in the properties here by double-clicking on the component, and here you go. Okay, if you want to stack this block of valve, you may need to have another lines here. So to do this, you just activate the link command and you drag and drop from the starting to the end of the block. Okay, you do it to extend these three lines here. And that's it. Now you have your manifold built accordingly. Okay. Now that I have this block, I can frame all these components. Because I break the lines now, I can select all the components inside my manifold. And you can group or assemble. You can group or assemble these components. Or you still be able to right-click on the group and click on Assemble. Now I have a block that can be duplicated and that you will be able to stack just like this. Okay, so basically you see nothing special in this version 6 according to the design. It's just a new interface, okay, where you place components. So Home tab, you draw, you break links, You can insert a BOM like you were able to. I will discuss a little bit more later about this. You still be able to insert reference, so you click on the component. You can reference, of course, single component. You can reference also manifold or component inside the manifold. So I reference, if I go in the BOM, the same that it was at 5.7, you have the filter branch. So you choose on which diagram you want to have your components. You go in the field tab, okay, and I will filter them by reference. Okay, so you bring this here with the arrow. You just change which column you want the first one and the order of your column. And now you see you begin to go a little bit more in the documentation of your project. Okay. Now this is okay, beautiful. I have a circuit that is drawn and nice looking, really easily. Okay. What I may want to do is start to analyze this circuit. So most of the analysis tool will be in the simulation tab. But this is really important to understand. You should never start to analyze a circuit if you are not sure about the hydraulic environment or the pneumatic environment. What I mean by pneumatic environment or hydraulic environment, Automation Studio is taking into account the oil that you are using and the lines that you are using. So it's useless to try to have some precise results without making sure that the fluid environment is exactly the one that you want or that you will have on your real machine. So to do this, I go here in the Automation Studio icon, and I will show you a couple of things that you should set prior to start analyze your circuit. So if I go in the project properties, starting from the top, in the project properties, you will see, okay, I don't want to go too much in details. We're going to explore this tab in a further webinar on standards in a couple of weeks that will be held. But I just want to show you a couple of things that we can take into account when you start to simulate. Okay, you can make all the lines as perfect to start the basic simulation. You can also have the thermal simulation that you can activate or not. We have now also the cavitation simulation capacity. Okay, the bulk modulus simulation is to take into account the compressibility of the oil. And the steady state evaluation, this is a more advanced feature that we can discuss later if you want. But basically, thermal, cavitation, and bulk modulus, okay, with perfect lines are options that you should try to focus on what you want to simulate. Okay. Once you have defined this, you can go here in the fluid system. I just want to explore a little bit things that can be defined. But as I said, there is a specific webinar that will be held at the end of the month. Okay. With this fluid system, you will choose which oil you want in your circuit and what are the default line types that you want to use in your project. Okay. So if I go in the line function, you define the line function that you want in your project. For example, you click here, and I'm going to define a suction line. Okay, so you define a function line. You can describe it if you want. So now I have in my project the capacity of using a function suction in my project. Okay, line appearance. You can define exactly the way the line will look as you will draw a specific function. Okay, so you can change it if you want. Fluid standard, less important for now, but you can define the default appearance of the component, nothing to do with the simulation. If you go in the hydraulic standard, you choose the function that you have and you link it with an appearance. Okay? So pressure line will be with appearance 1 and so and so. And really important as a simulation tool in the hydraulic installation, this is where you will set the simulation parameters of your oil. So the fluid environment, you set it here. The initial fluid temperature, really important. The ambient temperature, so you can simulate that you are in a cold temperature or really hot temperature. Atmospheric pressure, the air percentage that you have in your oil, and the fluid type. You'll see that by default you have many of fluids still available, but you can define your own fluid. And by default, you will see that for every line function, for example, I'm going to add my new suction line, you choose which line type you're going to use by default. So you can really save a lot of time, and the diameter that you set here will be taken into account in the simulation. Okay? So if you want, or if what you want to simulate is not in this list, you can click on this fluid and line manager here. Okay? And you will see that you can create the fluid you want. You can create some material with internal roughness, some line types. Okay? So this is also a new configurator for fluid and line manager. In fluid, if I click on new, you will see a couple of data that can be set, the bulk modulus and bulk pressure, density of the oil, the viscosity, really important to get good, okay, precision. And that's it. For the oil, you set what you want, and here we go. So now we close this. I will save, okay, this project properties now that I have. Before starting to simulate, you may want to set the line as you just defined them. So this is a pressure line. You can always go onto these lines and select all the line function that you want for your project. You see the suction line I just added. So I can really easily, I right-click here and I define this line as a suction line. I define this line as, by right-clicking on it as a load sense line. You see the appearance change. The same with this, which is a return line. You should have done this inside the manifold. Okay? So really easily, you define the appearance, the function, and you just right-click and you define the line as you want. So now I'm sure that the fluid is the right one I want to use, and the line are the right one that I want to use. Now I can begin to start the simulation. So if I click on this, you will see basically nothing happened, or I should say it seems that nothing happened. So to make sure that everything is right, I will start using measuring instrument on my component. So I will measure the input flow, okay, the piston side flow. I have a really small amount of flow that go inside my cylinder. Okay, so you click on these measuring instruments. You click, drag and drop, and remove. I will measure the pressure here. Okay, so I have a unload cylinder, no load cylinder. So I don't have enough flow. It may need that this orifice is too small. So what happens if I increase it? Of course, now I begin to get more flow here. Okay? Again, I just put a default pressure compensator here. You see the differential pressure is set to 50 bar, which is really too high, okay, for what I want to simulate in this circuit. And if I go in the pump, you will see that the maximum or the pressure compensator of this pump is set to 20 bar, which is not enough. I will put it to 200, and here we go. I've got a differential pressure of 14. Now I can return in my simulation, and I can increase this metering orifice and make sure like this that my circuit is behaving as I want. Okay? I open the plotter. Okay, this plotter was the same one that were available in 5.7. Still the same way of using it. You drag and drop the component you want inside of it. Okay. Drag and drop the pump. So output pressure, output flow. Okay. Here we go. And if I restart the simulation again, you will see that by actuating this, will make the value or the simulation parameters varying as a function of the time. Okay? So the same plotter that were available. So you see, compared to the 5.7, new interface, much more intuitive. You have all the design tool or the drawing tool here, all the edit feature to draw properly and change the orientation or the layout of your circuit. In the view, you activate the grid or not. You activate, for every component or for all of them, you have the ID that can be displayed or not. So you are managing the appearance of what you display on your schematic. You have some zooming feature here. There's a new view, so you can manage the view. So for the same circuit, you can create a new view if you want, of the same circuit. So so you have now two views in this diagram that I'm working on. One view here and the other one, and you decide on which one you want to work. And in the simulation, you have the simulation mode here. You have the plotter, measuring instrument. In the fluid dashboard, it's the easy way to access to simulation parameters, to modify quickly the simulation parameters. And the troubleshooting, it was presented last week, last webinar, on the basic feature. But if needed, at the end of this webinar, we will give you a survey, and you will be able to give other topics that you want us to build a webinar with, or give complementary information. Okay, so this is the basic way of using the software. Of course, as you start analyzing your circuit, you may want to dig a little bit more into the component properties. So for these component properties, just explore this cylinder to start with. You will see there is a major modification, but you see it's really easy to find everything in the same place. You will see now we do not have technical information split with the commercial information. What we have for every component, we have data. These data are regrouped here. You can navigate with this arrow to see a picture, the same picture that was available now. You can show it or not. And you have the list of all the data that you have in your circuit. So you can use the plus and the minus sign here. For this cylinder, we still be able to modify the extension of the cylinder, the piston diameter that can be modified. So if I change the piston diameter, you will see that now that this value is orange, means that you change this data. So all the components here, can be changed. If you have this sign here, it means that this is a calculated data or a calculated parameter based on the one that you insert. So the data that will influence the simulation, there is the technical characteristic here, regroup. So this is the geometry of your cylinder. For simulation, thermal simulation, use the heat transfer coefficient. For the load, for the external data, so this is where you input load to emulate the mechanical environment. You have access to the plotter variable, the operating condition, min, max operation, description of the component, identification, this is all the ID of the component that you put here, the name of it, and the commercial information. So the commercial information, this is where you put the part number to be part of the bill of material. You can put the manufacturer, unit price, description if you want. So the commercial information to be input into the BOM, this is where you fill it. So if I close this, I close this, you will see now I will return in my BOM, and you see that now my cylinder is identified by the part number that I just inserted. So you go inside the components you want to change. For the lines, again, in the technical characteristic, You cannot change directly the diameter. Okay, why? Because this is really to avoid mistake and making people don't know what they are doing. So we have some already defined lines. If you really want to have more flexibility on the internal diameter that you want to simulate, we have in this list a line, a custom line. Here we go. So the custom line allows you to define the diameter you want. Okay? So you set everything you need to. We still be able to simulate the elasticity of the line as a function of the material and the Young modulus. We still be able to simulate line elevation. Okay, so if you are working on the undersea system or a really high machine, you can put this at true. Okay, or you can individually, if you want, to make these perfect individual line as perfect. For example, in a circuit like this, really internally the lines may not be important that much to simulate the pressure drop of the internal path inside the manifold. You can, but if you want, you cannot. You can ignore them. But for the lines that you have from the pump to this manifold, it may be more important to set the pressure drop properly. Okay? So all the components get their technical data where you set the properties that will influence the simulation. Okay? So it will just take 1 minute, just see a couple of, not to answer them, but just see which kind of question you have. And I will continue in 10 seconds, okay? Okay, all of these questions, I will answer them at the end of the meeting, okay? I just wanted to make sure that that I don't have question about you're talking too fast or we're not able to hear you. So technical question, I will answer them later. Okay. So now now that I just show you, as I said, the designer way of using the software. You don't know which manufacturer you want, or you want to test some pressure drop inside the component that you are not sure at, or okay. But if you really want to use this software and really start to building some manufacturer's component, I will give you now complementary information about the way Automation Studio is simulating, or the main philosophy of inside the components themselves, the way you can define the pressure drops or the performance of the component, and also, as we will see, the efficiencies of these components. Okay? So to do this, before talking about the catalog itself, I will go in my Home tab, in my Library Explorer, okay? And I will just drag and drop a couple of really simple components to start with. So now I will show you a check valve. Okay, I will explore a check valve. We will explore also, let's take a pressure reducing valve here, okay? I will also explore a more advanced component, proportional directional valve, a user-defined model. Let's take this one. And also, which is new and with a lot of improvement, if you go in the pumps, you will find and you will be able to find some swatch plate symbol, okay, that can be used either for open loop or closed loop circuit, okay. So an open loop swatch plate symbol. I will also show and explore this closed loop swatch plate symbol. Okay, so you see it's really the swatch plate only. You will need to have an external control valve to it. And also I will explore a little bit in the motor. if you go there, you'll see that we have some swatch plate motor to emulate really piston components. Okay, if we start with these simple components, this is some models like this that we are using in our cartridges valve catalog that I'm going to show you later. Okay, if I take this check valve, the way in Automation Studio that we simulate phenomena, we try to simulate as much thing as we can with curve. Okay, the curve that will represent the phenomena that you have. For this check valve, for example, okay, you have a pressure drop available. So you extend this. You'll see I select the curve here, and I can use the CV factor to increase the pressure drop that you will have in your check valve. All of these curves, you get here a button, really important. This is a general setting button. This is where you define the scaling of this graph. But more important, this is where you define the viscosity that is taking into account into this curve. Of course, in your project, if you are using an oil more viscous, the pressure drop will increase accordingly. Okay, so viscosity and specific mass, you define this. This will be the curve at 32 centistoke, for example. And you can also have more curve or curve network, I should say. Okay? So, which means that if I have a zero cracking pressure, this pressure drop will be taken into account. If in the data or in simulation I change this cracking pressure, okay, and I have now a 12 bar cracking pressure, this curve will be the one taken into account. So this curve network is really, really common when you open a manufacturer catalog or manufacturer specification to saw them. So for a check valve, it's still a really, really simple component. It will block the flow in one direction, and it will allow the flow to go in the other direction if the cracking pressure is higher than the pressure is higher than the cracking pressure you set for this component. And of course, as a function of the flow, the pressure at the input will increase according to these curves. Okay? So this curve philosophy in Automation Studio, you can find it also in other components. If I take this pressure reducing valve, we still have the pressure drop curve, but since this component will start to regulate the pressure at its output, we have some performance curve. So you can take the point of the curve and making the performances of these components decrease as the flow increases, for example. Or you can double-click on the curve and really managing the reduced pressure performance as a function of the flow the way you want to make sure that you will begin to approach manufacturer's specifications. Okay? If I take a more advanced component, this directional valve, I don't want to go now too much in detail because this directional valve can be part of a standalone webinar. So I just want to give you a couple of information. In the technical specification, you have the symbol that can be changed the way you want. Okay. You can define what will be the spool travel as a function of the input signal. So you can put hysteresis here, okay, in the valve, and you can make the valve move as a function of the electrical signal that you put into the solenoid. Okay, once the valve moves, okay, I will just hide all the curve and I will explain this a little bit. As the valve moves, as the spool travel of the valve is modified, you can have directly some flow characteristic out of the flow path that you have here, or you can have different path model. For example, if I take this flow path just here, which is represented by the green curve here that I can select, I can decide to different models. Most of the time, what we have from manufacturer specification, we have directly a flow curve as a function of the command or the spool travel. So you can define or use this model. So directly, you will get out of this valve the flow curve characteristic at a given 32 centistoke viscosity and a differential pressure of 10 bar. So if you have these conditions, as you move the valve, you will get exactly this flow. But sometime, or for other features, or for other valve function, you don't want a flow curve. You may want an orifice curve, where you get the curve aperture as a function of the spool travel. So a lot of flexibility using these valves. I will start shortly to explore the catalogs, and I will show you an example how easy it is to have a really complex valve built properly using this valve. Okay, right. Depending of the flow type that you decide or the connectivity that you decide, the pressure drop will be calculated automatically. Of course, most of the time, the manufacturer specification are neither a perfect orifice model or a perfect pressure line model. So we have the user-defined model. If I select this, I will be able to really manage the pressure drop the way I want to really make this proportional valve work exactly as it is in specification of manufacturers. Okay? I don't want to go too much in detail for this component. As I said, if you want, or if this is the kind of component you are using, you can tell us or give us the information that you may need a more advanced lesson on these directional valves. Okay? And really the last component that I want to talk is this new swatch plate model. If I click on it, you will see that you can have some stroke limiter to define a different flow depending of the flow direction that you are using. But the most advanced or the most important feature is the efficiency curve. There is two curves that you can insert. There is the volumetric efficiency curve. So you have a working pressure here, the efficiency in percentage, and this efficiency is given at different speeds. So with these data, you can really insert in your project the efficiency of the realistic pump that you are using. Okay, according to the manufacturer specification, if there is enough information. So there is the volumetric efficiency tab, and of course there is the overall efficiency curve. The mechanical efficiency is extrapolate or is calculated based on the volumetric and the overall efficiency that you set here. Okay, by default, these efficiency curves are not activated. So really easily by using these parameters here, you can activate or not the efficiency curves of your pump. Okay? So depending of the complexity of the simulation you want or things like that, you can activate or not the efficiency curve. Okay? Again, this swatch plate, or I should say the way you can build a piston component or variable displacement component, can be a part of a future webinars. So if you may or you are interested in that kind of topics, please let us know. Okay? All this introduction to really switch in the last topic that I want to discuss with you for this introduction webinar. I want to discuss about the catalog manufacturer. So this job of inputting the curves and inputting the parameters inside the components, there is contains some slip-in valve, industrial valve, okay? And there's a lot of people, maybe some of you on the phone, get the request of inputting some DO3 or DO5 valve. We did this for Eaton, in the Eaton valve catalog. Some of you also that are more working with high flow or industrial field, we have and still have most of the slip-in Eaton valves that are working really fine. We already built a lot of projects with them. We still have some more advanced proportional valves. And we get all the screw-in available, which includes the integrated hydraulic acquisition from Eaton. So if I go in the flow control valve, or you see now that there is a mix of integrated hydraulic components and Eaton components. Okay, now all a part of Eaton. The HydroForce catalog, which is exactly the same architecture than iDesign, which is a configurator. If you need more information about it, we can discuss later. In this HydroForce catalog, you will see that compared to the version 5.7, we still have the data information, picture of components, some document. Okay, right away the PDF is still in these catalog. The test bench that I'm going to discuss later, you can put notes, accessories. We didn't do so far, but we input for these components all the 3D view of the valve. Okay, so what it means in this catalog, we also input all the configuration options that can be defined for this valve. For example, okay, if you look at the symbol here, if I put a manual override, here you go. Of course, the 3V view is updated, and you will see that if I click on here, this view also is updated. And now I will have a configured component ready to use in HydroForce. Okay, so for the cartridges catalog, we still have the Comatrol catalog. We still have the Delta Power catalog. The Sun Hydraulic catalog is still there. And for more advanced component, we still inputting based on your request, on customer's request. We still put in this Automation Studio catalog available for every user. We put more advanced functions. So you see, we still have some advanced motor, okay, a servo motor or two-speed motor or regulation motor, okay, an A6BM from Bosch, request a lot. Braking valve, the Myco one, some Bosch one. The cartridges valve for the someone and the Comatrol one, they will be removed because we have now the complete catalog. For the control block, a lot of requests of the PVG32. You see, this one is removed because we will shortly have a PVG catalog available. Okay, here we go. Some pumps available, still have some steering, some valves. In the Eaton pump that will be released soon, we are already inputting these new swatch plates in these models. So, in the pump point of view, the Eaton pumps contain really a lot of really good simulation model of closed and open loop circuit. And also in the Soward and Foss catalog, shortly available, it contains, okay, most of the options that are available on the catalog. Okay, so using these catalog, I will just move this a little bit. I will start to build, okay, a PVG32 valve stack using the catalog. So what I do, I go here, I select a pump side module, I drag and drop here on my circuit. I may need some basic module with pressure pump or not. Okay, you drag and drop, and you see that it will fit perfectly. Okay, so some of you, I know that some of you already request some components, and we build these kind of components per request. Okay, So basic module, you decide which spool you want, and you'll see the spool will fit perfectly where it should. Okay, you'll see that now that there is some space here, so you can add some shock valve or suction valve if you want. Okay, it should be like this. You can use the flip command. Oh, sorry. Control this one, use the flip command, and here we go. Now you have a protection block on this valve. And, of course, okay, in the BOM, all the catalog information is already inserted in the catalog that we provide. Okay, so if I return in the filters, in the field, I will just show you that if I input the manufacturers somewhere in my field, all this information, Sauer info, the hydroforce valve that I just inserted, okay, with the part number and so on. Okay, so this is the way you can easily build a whole machine using the catalog in a couple of hours, and by knowing the fluid environment and things like that, you can start using them. Okay? In these catalog, as I said, this catalog, if you want more information, we can spend more time specifically on this catalog or on these catalog. What I wanted to show you, okay, I will start with an Eaton pump, okay, a 72400 series, if I take the electrical, the first one. In the document tab, you will see that all the components that we have in Automation Studio are tested. What is the test? Okay, what a test contains. So if I take in my Project Explorer here, I will open the flow test for the Eaton pump. Okay, so just wait a little bit. Okay, my flow test should open shortly. So as you see in this Project Explorer, we are not only testing one thing. Now we are testing the flow. The efficiency may be or may not be tested, but we prepare the test for you to insert the curve you want and things like that. Okay, so in my Eaton flow test for the pumps, okay, you will see that for those of you that are not used with our test bench, we have some instruction of how you should manipulate the test. Really important to have a look at this, okay, before starting doing some tests. We have some joystick and some curve. This curve is picked directly from the catalog. So if I start the simulation, I'm looking at the instruction, and you decide or you change the speed, okay, the shaft speed. You manage the shaft speed. So this is the x-axis of this graphic here. And you change the displacement of the pump accordingly. So what you have here, it's a test as maximum displacement. So I will actuate or the full displacement of my pump. And here we go. I can now change the shaft RPM, and my curve is followed perfectly. Okay? If you look a little bit deeper in the components, you really see that this swatch plate, okay, this is the model but with the Eaton symbol. Okay? If you change the displacement, the flow is modifying, but you see that the control valve always returns to the middle position as the desired flow is reached. You can also change the working pressure in this test. So with this test, we can pretend that this pump gives you the right flow as a function of the input. Okay, this is one example of how you can use the test bench and the way we are testing every single component that you can use in your project. Okay, if I take another test, I will open a PVG 32 components. Okay, I need a valve here, so I will just go in my Automation Studio, sorry, PVG32. I will take proportional valve here, and I will input it in my test bench. And now you can see, okay, as discussed, that if I move this, I will get exactly the desired flow, okay, as expected. Okay, this is a pressure control spool, so I'm okay, show you the principle. This is not a good spool to use for this test because it's a pressure control spool that we have for PVG32. So if you take one with flow control spool, now this test is more suitable and you will get out of it. Okay, you will get out of it exactly the flow that you want. So no doubt that this is an A spool valve. Okay. So if to conclude with these test benches, or to move forward with these test benches, as discussed in this simulation, there's not a lot of complex things. There is this pressure pump, really important. This pressure pump will maintain a differential pressure of, I think it's something around 8 bar for Sauer and Foss. And inside this valve, if I return where I was, okay, previously, if I go in my area flow, you will see that from port P to port A, which is your control port, you get exactly this curve. So you copy and paste from the catalog in our model, and this curve will be followed if you have a device that will maintain 8 bar as a differential pressure. So based on this, you can use our manufacturer's catalog to really, okay, as is, if you don't have that much time to play with this, or as a samples to really create your own components as you need. Okay? The last thing that I want to show you in the catalog is about the efficiency that we have now. So this is a Sauer and Foss motor that we have, where we insert some efficiency curve as it is in the manufacturer specification. Okay? If I start the test, I fix this control valve because I want the first test to be performed at maximum displacement. Okay? As you have in the title of the graphic here. Okay? So I move the pump displacement, so I give, okay, a small amount of flow. And because I don't have any working pressure, my efficiency will be, my volumetric efficiency will be really good. Okay? But as I increase the resistive torque, okay, I will just zoom a little bit here. So, as I increase my resistive torque here, okay, when you will reach your 210 bar, you will follow exactly this curve. And if you add more pressure, of course, the efficiency will drop. And now at 420 bar, you will begin to follow this efficiency curve. So now you have a really a realistic motor, exactly as you see in the manufacturer catalog. So if, again, I change, okay, the flow that go to my motor, you will see that my curve, efficiency curve at 420 bar is followed perfectly. So with this version 6, this efficiency now available, we only begin to input some efficiency inside the component. Don't expect so far for us to put all of them. Why? Because most of the time these efficiencies are not provided or are not public information for manufacturers. And sometimes also the efficiency is only given at maximum displacement or at some specific point. But if you need in your project, we can help you, or we can do a webinar dedicated to this more realistic simulation. So it's 5:10 my time approximately. So this is the end of this 1 hour webinar. I hope this, as I said, it's really an introduction of everything that can be done in your fluid design and application. If I just recap a little bit what we cover, I explained how easy it is, or how easy it still is with this version to draw, okay, a really nice schematic like this in a couple of minutes using the generic library or the manufacturer catalog. Some feature to edit or change the layout, how you can manage what is displayed on your schematic or what you display of your schematic. Simulation tab, okay? In the fluid, this is where you set your fluid and line manager, okay? And we discussed a little bit also, really important. If you can remember, first thing from this webinar, it's always have the reflect of setting the fluid environment before simulating, okay? So I hope you enjoyed this little fluid power introduction.